Okay, we'll solve number 2 from chapter 6, hard questions. Number 2 tells us to refer to scenario. Scenario reads, let the supply and demand curve for gallons of gasoline be the following. P equals 2Q and P equals 12 minus Q. Treat each question independent of each other. Question 2 asks, suppose a tax of $3 is applied in this market. Which of the following outcomes would result? Q equals 5 and consumers pay $10 per gallon. Q equals 5 and revenue per gallon is $10. Q equals 3 and consumers pay $6 per gallon. Or Q equals 3 and revenue per gallon is $6. Okay. So we're given a supply and demand curve. Right, so supply is 2Q. Demand is 12 minus Q. And the tax that's been applied in this market, the size of this tax, is $3. So we want to know what the result is on the economy. So first, let's visualize this with a supply and demand graph. Demand, supply. Okay. So how can we see how a tax affects this market? Well, the first thing you can try is something called the wedge method. All right. So the wedge method simply says to find the distance between the supply and demand curve on the left side. That is the size of the tax, $3. Right? And this, you're essentially creating a wedge here. Right. And so what we're given here, once we do this, we create this wedge, is we're given the price that consumers pay, the revenue per unit for the firms, both after the tax, and then the quantity, the equilibrium quantity after the tax. So this is quantity after taxes. This is what consumers pay. And then this is revenue per unit for firms. So with this information, we pretty much can answer all our questions, right? Problem is that we're being given equations. So if you're given a graph, then well, you can just look at the graph and you can answer these questions. Pretty simple. The wedge method works very nicely. But if you're given equations, we don't have this. We don't necessarily have this luxury, not easily. So what we can do is the method we originally learned, which is shift either the supply or demand curve. Now we know that we can shift either the supply or demand curve, and it doesn't matter in a perfectly competitive market. The end result is the same. So we're going to shift the demand curve down to the left to reflect an increase in cost. And the distance that we're going to shift the demand curve down is $3, 3 units, which is the size of the tax. We know that this shift here should be correct because this distance here, this wedge that we created, is $3, right? And so this distance between the old demand curve and the new demand curve should be the same. It should be that $3 all the way on down. Well, here we get the equilibrium quantity after taxes, which is the intersection point between the shifted demand curve and after taxes, the after-tax demand curve, and supply. So we can call this after tax. Right. We have this intersection point that gives us the quantity and then the revenue. Add the $3 to the revenue, and that'll give us what the consumers pay, which is just this vertical distance from here to here. So with that, let's solve this question. So first, we're going to shift the demand curve down, right? And of course, if you wanted to, you could shift the supply curve up. I suggest on your own, you try doing that and see if you come up with the same answer. So the demand curve is 12 minus Q. If we want to shift it down 3 units, we subtract the entire function by 3. We know that from algebra. So now we want to find this intersection point here. So we've shifted. So this would correspond to the after-tax demand. And then this up here is just supply. And this would be demand. It would be before tax, of course. So now we want to find this intersection point here, right? So we're going to find the intersection between supply and after-tax demand. So after-tax demand, if we do the algebra, 12 minus 3 is 9, Q is by itself, and supply, which is 2Q. Again, we just do some algebra. So we put the Q on the other side, so 9 equals 3Q. And so Q equals 3. And so this would be the quantity after taxes. And then we can find corresponding price on the y-axis, plugging this either into the after-tax demand or into the supply curve. So 9 minus 3 is 6, or 2 times 3 is also 6. And this would be revenue per unit for firms. Right. So after taxes, the firm will receive $6 per unit, and they're going to sell 3 units. The consumers are going to buy 3 units, in this case, gallons of gas, right? And so what are the consumers going to pay? Well, we know that the consumer is going to pay, so we'll call this PC. We know that the consumer is going to pay $6 to the firm, but then they have to pay $3 to the government for taxes. And this will give us 9. This is what the consumers pay. So if we go to the answers, A and B can't be correct because it says that after the tax, Q is equal to 5, but indeed Q is equal to 3. For C, it says that the consumers pay $6 per gallon, but we see that the consumers pay $9 per gallon. So the answer is D. Q equals 3, which we found, and revenue per gallon is $6, which we also found.